Okay, I have a new question. A block is initially at rest at the bottom of a slide. James pushes it 2 meters up, parallel to the slide. The applied force is 620 newtons, and the force of friction is 220 newtons. The block of the is 72 kilograms, and the slope is 30 degrees. Okay, so let's have the drawing drawn instantly. So we know the slope is 30 degrees, so we get that. The block is 72 kilograms. We're going to put here, and we call this 72 kilograms. So we're going to say, because the mass stays constant the entire time, so we're going to say that mass is 72 kilograms. Okay, now we know that. We want to determine, we want to draw the free body diagram of this. So let's just draw all the forces. So gravity goes down. Force of gravity, force of friction, force of normal, force of applied because it's being pushed up. And let's draw this now. And just do the exact same thing. Force of gravity, force of normal, force of friction, force of applied. Yeah, okay. So now we have this graph and this diagram, and the question is asking us to find every single force on here. So this is like similar to the quiz that we did on a test, but the numbers are fudged up a little bit. Okay, so first we have to figure out the velocity. So we always have to label in the velocity 1 velocity, H1 or H2. So velocity 1 is 0 because it starts at rest, and height is 0. This height is so it's 2 meters, so this is 2. So just do sine 30. H equals sine 30 multiplied 2, so it's just 1. Just write 1 right here, and H2 should be that. V2 is undefined because we don't know what that is yet. And now let's go back to the question, and well, it gives us the applied force is 620 and the force of friction is 220. So let's start with the applied force, the work of the applied force. So you all know that the work, one of the work equations is this one. Work equals blah 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 blah. We should all know that by now. Okay, force of applied was 620. The displacement was 2 cos theta, so it was 0 degrees because it's parallel to the displacement. Always draw this on the test. You never know when you get it wrong. So that's 1, and then you get 1,240 joules of work for work of applied. Square it so you don't forget. Friction, let's do friction quickly. It should be pretty much self-explanatory. Mr. Colterman does not care if you do that, don't worry about that. This is -1 automatically, so it's 620 multiplied by displacement, which is 2. Wait, no. Oh my gosh, I'm misreading stuff. Okay. So this is -440 joules of work by the force of friction. Now we have the force. Oh, I'm getting tired just by holding this camera. The force of normal is always 0, and the work of the normal is always 0, and the work of gravity. So this one's a little bit more complicated since the gravity, as you can see, is like pointing downwards, and it's not 90, it's not 100, and it's not 0 degrees. So what we know is that it's pointing straight downwards on our side. So if something's pointing straight downwards and there's a slope and it's pointing straight downwards, what is the angle here? I'll just say, what's the angle here? Well, we automatically know theta is like this, so it's theta equals 180, subtract 90, subtract whatever this angle is. We already know it's 30, so it's 30, and then we should get 60, so theta equals 60. So now we know this is 60. Just write 60 here. Shoot, my fault. We need to find the angle between the displacement and that. So displacement is here, and this is force of gravity. Well, it's basically the same thing. We have 60 here, and then we just get 120 here because 180 subtract 60 equals 120. And then what we do here is just make this equal to force of gravity. Which force of gravity? We'll just write down the equation first, just so we don't get confused. and let's automatically put in the angle in, so which is 120 degrees. And then the force of gravity is, we learned this in dynamics, is mg. I was hoping that you know, like, fill it in before I say it. Displacement is always 2. Cos of 120 is, pretty sure it's -1/2. And then we just get the mass. What was the mass? 72 kilograms. That's why you label your stuff properly, and you should get. I gotta use the calculator. I'm not that smart. I'm not like Mr. Colterman doing it on the spot. I wish I was, but I'm not him. I'll never be him. Okay, -705.6 joules of work by the gravity, 0 joules of work by the work of normal, and 1,240 joules by applied force. So on a test, you won't have time to think. You will only have time to write. That's why my analogy is every single time I take a test, I'm not thinking, I'm writing. Because it's not like a trick question. It's always has a solution. Let's just say that. Okay. So now we get the work of net, and it equals. So you just say therefore all your forces, blah blah blah, work of A, work of F, work of G, work of normal, but write in full sentences so you don't get marks off, and just say whatever they are. Okay. So now the second question asks you, what is the speed at the very top? Okay, if you don't know what to do, don't worry. If you have all these numbers, work of normal, work of friction, work of gravity, work of applied, what can you do? You can find work of net. You just add them together, okay? So you should get this plus this, -440 joules, plus -705.6, plus 0 joules. And you should add these up, and you would get, I actually want to do this in my brain this time. 94.4. How about that? 94.4 joules. So that's the work of net for the entire system. Let's write it with our calculator. So we have 1,240. Subtract 440. Subtract 705.6, and we should get 94.4. Yes. Am I the smartest man alive, or am I just the smartest man alive? I don't know. Am I? I couldn't tell you. Okay. Oh, shoot, I'm getting distracted. The block is 72 kilograms. So, yeah. Now we have the work of net, but we also know that the work of net is also this equation. And what is this? This is the change of kinetic energy. Change of kinetic energy. Because it's... Whoa, the camera's not focusing. So this is the formula for every single formula. So we can just use this, and it has velocity. When I don't think we need height in this. Yeah, we literally did not need height at all. I don't think so. I don't think we're gonna use height at all. So I think getting height was like useless. Well, just do it just in case on the test. You never know when Mr. Colterman asks you what's the height, and you're just stumbling on your feet. You're like, what's the height? So this is equal to 0. So I like to just say this is equal to 0, and you just cross it out. And you get this, and you get this, and you get that, and you get this. And then you multiply both sides by 2. And you divide it all by 72. And you square root everything. And you should get 1.62 equals velocity 2. Therefore, the final velocity is 1.62 meters per second. Alright, that's how you do it. That was a really, really long solution, by the way. Holy crap.